Hello? Hello? Can you guys hear me? Hello? Can you guys hear me? All right, so let's give it one more minute before we get started. Today is the first lecture for the new session. So according to my previous experience, a lot of students might have some connection issues. So let's give it 1 or 2 minutes while we're waiting for more students to show up. Okay. So like I keep suggesting, for the first lecture, it is better to be arriving here at least 10 to 15 minutes earlier. Just try to make sure there's no connection issue or, credential issue, so on and so forth. Let's give it 1 more minute while I'm trying to help out the other students. Okay, bear with us. All right, I think for now it's 8:33, so let's get started. Hi, welcome guys. Welcome to our session 3, 2D geometry. Yeah, I see more and more students are coming in. Okay, so welcome to our new session, session 3, 2D geometry. So as a common practice, at the very beginning of each session, I want to spend roughly 3 to 5 minutes, give you guys a quick introduction, talking about the organization of our lecture, how our lecture works, especially for the new students. Okay, fairly quick. So this is like a basic introduction. For our lecture, I think the interaction is the most important. These days, due to the COVID-19 situation, I think most of the students, they're becoming more and more familiar with these online lectures. Rather than previously, you see the teacher face to face. Well, these days, it's pretty much these interactions over the internet. I believe in what kind of circumstances this involvement and interaction is actually more than important, right? So even though I can't see your face, but I really like you to get involved into the discussion process. We actually have 2 ways to get you involved into the lecture. The first way, which is highly preferred, you can just try to unmute yourself. By default, as long as you enter into the classroom, you'll be put into mute. But you can always unmute yourself during the entire lecture. So as long as you got a question or you don't really understand what I'm talking about, or you might have some different opinions, always try to stop me anytime you think it is necessary. Unmute yourself and raise the question directly. So pretty much like a real lecture, right? You raise your hands, you basically talk with the teachers, your questions can be heard by the other students, okay? Well, the second way is also pretty much very helpful. You can actually chat with us. I assume you should be familiar with the Zoom application, but if you're not, so basically you see there's a control console. In the very right corner of the control console, you should see 3 dots saying more. You click that option in the drop-down menu. The first option should be a chat. You click that chat, you'll be brought into our chat board. You actually have 2 ways to interact with me and the other students. One way is you basically send your message to everyone. This is going to be public, so everyone can see your questions, and see your response, so on and so forth. Well, the second way, if you feel a little bit shy or you're not so comfortable, or maybe your question feels like more comfortable talking with me individually, you can talk to me using the private chat. You basically find my name in the drop-down list, and the message will only be seen between you and me. But I think this is like a class, right? This is a learning process. No one should be judging others. So I think it's not a big deal. You can always use the public chat so everyone can see your answer. All right. Second one is the homework. Every single lecture, we're going to give you guys 3 problems. So these problems are specially designed. I try to reflect the topics that we talk about during the lecture. You might see a lot of similarities in our sample problems and our homeworks. And these are pretty much designed for help you guys to make an extension of our lecture. So every time when you finish your homework, try to submit it at least 1 day before the deadline, before our next lecture. So these give me a lot of time. Basically, give me enough time to mark your homework. In the next lecture, I'm gonna invite some students to give us the presentation. So as long as you did the homework correct, I'm gonna ask you to present your homework in the next lecture. So trust me, as long as I ask you to present your homework, it means that you did a good job. So I'm not going to make you like a fool, right? So if you did it right, I'm going to ask you. If you do not did it right, so I'm not going to ask you. So that being said, whenever I ask you to present the homework, you should be, what should I say, more than confident because you have the correct answer, right? This participation is always very important for the entire course of our lecture. The third one is the language. So our lecture is pretty much focused in English. And a long time ago, people can speak, according to my experience, long time ago, my lecture is like a bilingual English and French. But these days, I realize less and less people, they can speak French. So it's pretty much our language is going to be only English. But you know what, just for my information, I think if you can speak some French, it's going to be very helpful for you, what should I say, leaving Canada, especially sometimes when you're in Ontario, you want to choose the service in English, you're pretty much going to late for super long time due to this COVID-19 situation. Well, if you choose pour la service en français, you're pretty much going to, get your answer connected right away. So, it was only kind of like a suggestion. If you want to live in Canada in the long run, it is very good if you can speak some French. All right, just kind of like an information purpose. And the last one is the presentation. Our lecture actually focuses on not only the knowledge itself, but also how to build up this capability and this learning capability and presenting capability. I know a lot of students, they have their goal and they want to go to like the top tier tech companies, in the future, like Google, Amazon, Facebook, so on and so forth. And you guys may know that one of the most important evaluation purpose for those top tier companies is actually a code interview. Okay, so, but their code interview is kind of like different versus our regular code interview. So in those job interviews, they're gonna ask you to solve a problem for sure, but at the same time, they want you to present it on a whiteboard. So you're not really coding in the pretty small cubic, right? You're actually coding a whiteboard. So while you're coding, you need to, what should I say, present your answer to the interviewer. So you need to really think aloud to guide the interviewer the entire thinking process. So we always say something like this, if you know something, it is good, but it's even better if you can present, right? Speak it out. So that being said, every lecture, starting from the second lecture, we're going to be asking one student to give us a presentation. You can find like a tiny problem, not necessarily a super complicated problem that blows everyone away. It just got like a simple question. You can Google from the internet or your homework, so on and so forth. As long as the problem is kind of related to our lecture, aka our 2D geometry, you're more than welcome to give us this presentation, roughly 3 minutes, and try to walk us through the solving process. Not only read the solutions to us, but also walk us for the entire thinking process. All right, so yeah, I think that's pretty much what I want to say for the very beginning, a short and brief introduction. You have any questions? All good, all right. So in that case, let's jump to our first lecture. Okay, our first lecture is gonna be triangle and its properties. Triangle and its properties. You know why I choose triangle as the very start of a lecture? Because I believe triangle is like the basic elements for all those geometry problems. Think about it. All the geometry problems that you saw before, you pretty much every single part, you can find the triangle things. So the geometry problems, think about it. The entire geometry problems can actually be divided into three major categories. The first one is problems calculation of segment lengths. So here calculation not necessarily means pure calculation. It might be a combination between calculation or proof. But nevertheless, the first category focuses on the segment and its length. The second one is also calculation of angle. The last category is calculation of area. Think about it. Try to use our experience that we saw before. In the first category, you might see some problems from time to time ask you to calculate what is the length of a specific segment, right? Or they want to ask you to do a comparison between two segments. Maybe the two segments are the same in length, or maybe one segment is 3 times of the other segment, so on and so forth. But how are you going to do that problem? At the end of the day, most of the time, if you want to prove two segments are the same, maybe you want to put them into two different triangles and make sure these triangles, they are congruent, right? Think about it. Or if I ask you maybe the relationship between two segments, maybe AB over AC equals, I don't know, CD over CE, for instance, if that's the case, so most likely what you're going to do is you're still going to put them into two triangles, triangle 1, triangle 2, and try to prove these two triangles are actually similar to each other, right? Taking from there, you'll be able to find out the proportional relationship between different segments. Think about it, right? These are pretty aligned. Everything should be go to a triangle and solve the problem from a triangle. Then what about the second category? They're trying to calculate or prove some angles. You know, prove some angles maybe ask you to determine the measurement of an angle, or most of the time trying to prove one angle is the same as the other angle, or one angle is 2 times, 3 times as the other angle. So these kind of things, again, you still want to put them into triangles, try to prove the congruency or the similarity, right? Also, you can see triangle can be used to solve this problem. And also, another very important point that has been tested from time to time is actually the area. You see, the question might ask you to determine the area. Sometimes it's a triangle area, sometimes maybe quadrilateral area, sometimes maybe like polygon, right? Something even more complicated. But think about it. Most of the technologies we learn how to determine the area of a shape is actually what? A triangle, right? We know some different technologies how to determine the area of triangle. So that being said, if the question asks you to determine the area of a quadrilateral or like even a polygon, most likely you're going to break them into different triangles. Is it right? Break them into different triangles and you can solve the problem in different triangles. So that being said, you can see most of the geometry problems, the triangle is actually our prototype. If you have a very good understanding about the triangle properties, this is going to be very helpful for all your geometry related problems. All right, so that being said, we really like to start our lecture talking about some basic properties of triangle. After you have a very good foundation, we can actually move on to some other different topics. But trust me, most of the topic, or if I'm saying almost all of the topic, are actually based on the triangles. All right, if that's the case, let's go to our first part. We just want to give some very good introduction and a summary about all the properties of a triangle. So let's go to our lecture number 1, triangle basics. Okay, I would say for the following properties, most of them should be very familiar to you guys. We just want to take this opportunity to do some summary, right? Summarize all the things together instead of letting them scattered all over the places. Okay, so the first one, is the essential inequality within a triangle. If I have a triangle, ABC, ABC, without talking any specific features, as long as I have a triangle, I should automatically have the triangle inequality, which I think you guys should be familiar with. So triangle inequality goes like what? The sum of any two sides must be greater than the third one, right? This is actually a group. At the same time, the difference of any two sides must be lesser than the third one. Is that right? These are like the basic information you know before. So that being said, as long as you have a triangle, you automatically have 6 different equations. So my next question for you guys is that, are these 6 different equations that are independent, or they have some relationship between one and another? Are there 6 different inequalities that are independent? Means as long as you have a triangle, you need to list out all of them, or some of them that are actually dependent on the others. So why I'm asking this question is because one day I might give you a triangle, I let you to list out all those inequality relationship. Do you really have to list out them all, the 6 different inequalities? Or you can kind of ignore something because something can be derived from the other things. This is my question. Yeah, you can actually post your answer into the group chat, so I'll be able to see this. Yeah, I see some students have different answers. Yeah, some students said you can just add up the smallest, right? And you can just say like sometimes find like the largest. Yeah, and the other students said they're independent. Okay, actually, I have to say these are not independent. Why? I'll give you a quick information. Check it out from here. This A minus B is lesser than C. Actually, if you do a quick arrangement, A is lesser than B plus C. Is that right? So this is exactly the same as this guy, right? So these two things can actually also be derived from the plus relationship, right? I think this is understandable. So that being said, from these 6 different inequalities, at least all those minus related inequality, they are not independent because they can be derived from the plus related inequality, right? Are we on the same page? So 50% you can drop. So what about the remaining 50%? When we have only these 3 inequalities, are they all independent or they're not all independent? This is actually my second question. Now we know 50%, they're not independent. We're just gonna cross them out. And we just focus on the plus relationship. Are these 3 things independent or they're not independent? Again, please post your answers in the group chat. I'll be able to see your answer. Okay, I see some students have some trials. Yep. Yeah, students saying that you need to compare like the lengths, the longest, the shortest, they might have different properties, so on and so forth. All right, that's actually a very good direction. Just the correct answer is these 3 formulas, they're not 100% independent. It really decides, it really depends on the shape of this triangle. If this is acute triangle or this is obtuse triangle, you might see different formulas, different 1, 2, 3. Sometimes 1 and 2, they're independent. 3 is not independent. Sometimes 2 and 3, they're independent, while 1 is independent. Okay. However, trust me, if you want to spend a lot of time talking about, okay, this is an acute triangle or this is an obtuse triangle, and at the end of the day, you figure out which formula is independent, which formula is not independent, trust me, this is totally worthless. In your North American math competition, you always list them out, all, list all, okay? Without really spending any time to discussing which one is independent, which one is not. Because your worst, like your worst case, you just actually calculate one thing for nothing, right? At worst case, it's basically you have like one formula, you list it, you try to calculate it, but it doesn't really make sense. But no problem. I think it is always easier to close your eyes, blindly list out all those 3 inequalities, and just directly do the discussion. Okay, you guys hear me? Because as long as we go to like the AMC problems, you're gonna find out sometimes it is always easier to list them out right away rather than doing any analysis. Okay, this is actually my first topic I want to talk to you guys, the essential inequalities in a triangle. Second is actually something very understandable. So I have a triangle A, B, C. Let's say this is 1, 2, 3 angles. So all the angles sum are going to be like 180 degrees. And this part is more important. Angle 4 equals to angle 1 plus angle 2, right? The external angle will be the sum of those 2 not adjacent internal angle. So this property, I know it's very easy, but this is actually very important because AMC and our Canadian exams keep testing them from time to time. Try to remember this. Okay. Number 3 is our bisector related property. A, B, C, P. Given a triangle, and AP is the bisector of BAC. Okay? If AP is the bisector of BAC, means angle 1 is equal to angle 2, right? Then if I have a point E on the bisector, I want to make 2 perpendicular lines to the 2 sides of this triangle. So automatically, let's say this is D, this is F, then automatically you should have DE equals to EF. Is that right? So these 2 segments must be the same in measurement because any point on the bisector of an angle, it should have the same distance to the 2 sides of the angle. All right, I think this is quite understandable. And trust me, in the real math competition, AMC or Canadian math competition, they really barely tested for this. As long as you see a triangle has a bisector, your first reaction shouldn't be a point has the same distance for the 2 sides. On the contrary, it should be the bisector theorem. We'll talk about this bisector theorem in a bit, okay? But here, for being completeness, I'm going to give you this. AB over AC equals to BP over PC. This is the famous bisector theorem, and this is actually number 1 tested in all the North American math competitions. Later, we're going to give you guys a more explanation how we're going to use such a formula. Okay, let's go to number 4. So I have a triangle. ABC. I have 2 bisectors, BD and CE. Okay, BD and CE are bisector. Okay, if I have ABC is greater than ACB, then I must have BD is greater than CE. What is that? ABC. If this is bigger, let's say lesser, excuse me, lesser. Yeah, because my because my shape is pretty much ABC is actually lesser, right? If ABC is small, ACB is big, then automatically you can have BD is actually greater than CE. So that being said means what? A bigger angle, they must have a shorter bisector. Right? I think that makes sense, right? A bigger angle has actually a shorter bisector. So this property is it's very intuitive, but sometimes this is going to help you to solve some problems fairly quick. Without going the deep calculation, you can just directly using this conception to basically figure out what to do with the problem. This is number 4. Number 5, you know, we have this bisector have this kind of property. We also have another line also have this property. That is our median. Okay, so I have a triangle ABC, DE, AD, and BE. They are the medians. Okay, median means these two parts are the same, right? And these two parts are the same. Okay, if they are the median, and you have what? BC is greater than AE. So automatically, you should have AD is lesser than B. So BC is here. It's greater than AC. It's greater than AC. Okay, BC is greater than AC. So that being said, you're gonna have AD is actually lesser than BE. So that being said means what? Means again, the longer side must has a shorter median. Is it right? A longer side must have a shorter median. This is pretty much the same thing as a bigger angle must have a shorter bisector. So these two properties are actually very comparable. You're going to use them from time to time. Okay, this is number 5. I think these are quite intuitive, right? Number 6. Number 6 is actually a very understandable property. A, B, C, D, AD is the median. Then automatically you should have ABD triangle has the same area as the triangle ADC, right? These two triangles, they're actually having the same area. This is quite understandable, right? And we can see that actually these two triangles, they're sharing the same latitude and their bottoms are the same. So therefore, they should have the same area. These are quite understandable properties, right? Okay, so let's just continue. Number 7. Number 7 actually saying some important centers in triangle. What is that? Let's say if I have a triangle ABC, I want to make the bisectors of 3 different angles. Here, here, here. B prime, A prime, C prime. A prime, B prime, C prime. They're both what? Bisector. So the 3 bisectors of a triangle will actually intersect at one point. So this point, we call them the incircle. Okay, incircle center. Incircle center. And also, again, I have a triangle ABC. I have like what? 3 mediums. 3 mediums. A prime, B prime, C prime. Mediums. They should also intersect altogether at a point, right? So this point, we give another name. centroid. This is the centroid. Okay. Number 3, have a triangle A, B, C. I have 3 latitude. The 3 latitude on the 3 sides can also intersect at one point. Latitude. So this is what we call the orthocenter. Okay? Actually, we have even more. For instance, the 3 bisection of our 3 sides can also intersect at altogether. Bisection. Bisection for the 3 sides, right, means this is a segment which is perpendicular to the side and also cut the side into 2 equal categories, right? 2 equal segments. They will also all together, right? So you can call this the circumcenter. So that being said, we find out this is a very interesting property for these triangles. As long as the same type of segment means they're all bisectors, all medians, all latitudes, or all bisections, they will actually merge all together, and this at this specific point. And this specific point is actually having a lot of interesting properties. And as pretty much like some of the high-level math computation, they always ask you to, find out all those centers and use the specific properties of these centers, try to solve some problems. So in the later part of our lecture, we're going to give you guys some summary how to use all those points and how to use the flowery properties. Okay, so our first lecture is an introduction and also pretty much a preview for our future lectures we will cover for the triangle parts. All right, so today we just list them out without giving all the explanations. We'll talk about it later in our later courses. Okay, number 7, let's go to number 8. Number 8 is actually a very important and very interesting property I want to show you guys. I have a triangle. I have a latitude. And I have a bisector. A, B, C, AT, and AH. So these 2 things will actually include an angle theta, right? So given triangle ABC, AH is perpendicular to BC, which is the height, and AT is the bisector. Okay, with these 2 information, I will say that so angle theta must be 1/2 angle C minus angle B. This is actually a very interesting property. Sometimes if you know this, you'll be able to solve the problem without too much calculation. So the bisector and the latitude of a specific angle, they're actually gonna include a small angle theta, right? This small angle must be half of the difference of the other 2 angles in this triangle. Okay, this is actually a very interesting property. So think about it. What are we going to do? How are we going to do for such a problem? If I want to ask you to prove, give us a quick proof. How to prove this? So I think in order to prove this, because this is like a basic triangle, we don't have any flowery properties, right? We're just going to get started using the basic property of a triangle. So let's check it out from here. This theta, I need to prove basically 2 theta is equal to angle C minus angle B, right? This is what I need to prove. Let's have some quick analysis how this 2 theta looks like. Okay, this 2 theta can be written as a theta plus theta, right? So the first theta can be written as what? Angle BAH minus angle BAT. You see, BAH is here, BAT is here. Of course, theta can be written as this. This is 1. Considering you think about the left part, you're probably going to do the same thing for the right part, right? Can also be equal as angle TAC minus HAC. TAC is this angle, HAC is this angle, right? The difference between these two angles also give you theta. Okay, but let's check it out from here. BAT, TAC, BAT is what? BAT is here. TAC, TAC is here. Because AT is what? Bisector. So of course, these two angles should be the same, right? So these two guys can actually cross out. You directly get BAH, HAC. But the question is asking you what's the difference between like angle C and angle B, right? So of course, I need to basically replace the BAH and HAC using angle C and angle B, right? I think this is quite intuitive because BAH is just 90 degrees minus angle B, right? Because they're all in this triangle, right, triangle. So I'm gonna put into 90 degrees minus B. Minus, what about HAC? HAC is the same thing. HAC, they basically stay in here, right? In this small triangle. So this HAC will be equals with 90 degrees minus C. If you open the bracket, you're gonna have angle C minus angle B, right? So of course, I wanna put this kind of like, what should I say, a absolute value, right? Because I don't know B and C, which one is bigger. But nevertheless, this will be the difference. 2 theta equals to angle C minus angle B. So therefore, theta will be angle C minus angle B, absolute value, and divided by 2. Okay, this is our proving process. I think it's very understandable, right? But try to remember this is a very interesting property. Sometimes if you know this, you can save your time. Don't have to calculate too much. All right, so far so good. These are the basic properties, right? So I think these are pretty much what I want to say, talking about the basic properties of a triangle. You see, whenever you see a triangle, like a basic triangle, do not have any flowery properties, right? We just basically use all the sum, like all the angle sum equals to 180 degrees, and there's some relationship between all the angles and all the sides, and that's it. All right, this is like the basic introduction for those triangle properties. If we're all good, let's go to some real problems. Let's have a look without going to the congruency, the similarity, using the basic properties of triangle, what kind of problems we can solve in North American math competitions. All right, so let's check out the first problem. Question number 1. Question number 1, I need to draw you the graph here. Okay. Question number says I have a weird shape, A, B, C, D, E, M, N, F, G. I have a lot of angles. This is angle 1, 2, 3, 4, 5, 6, 7. Please determine the sum of angle 1, angle 2, angle 3, angle 4, 5, 6, 7. Okay, this is an easy peasy warm-up question. I give you the weird shape, and I give you all the angles one after another, and then I ask you to determine what is the total sum of angle 1 all the way to angle 7. Think about it. What are you going to do whenever you see such a problem? Question give it a weird shape, right? There's nothing really tangible, right? It's like this entire shape can be changing from time to time. But nevertheless, the question asks you to determine what is the total sum of all those angles. Okay, I see somebody try to give me the answer right away. Yeah, that's good. Think about it. Whenever we see such a problem, what are we going to do? So my first reaction, let's talk about my first reaction is, as long as you see them, they're scattered all over the places, right? You can either put them into triangles or put them at least into quadrilaterals, right? Because triangle have a total sum 180 degrees and quadrilateral is going to have a total sum of 360 degrees. I think that's basically where we're going to get started, right? But try to put everything into, let's use a quadrilateral, for instance. What can we do? So we see there are kind of two quadrilaterals in this problem. One is like this guy. So let me try to use the color. One is actually this. This is kind of like a quadrilateral which contains at least 3 different angles. Then I have another one like this. The blue one, right? The blue one also has at least, like 3. And there's a 1 dangling in the A corner. I just forget about it at this moment. But kind of as long as it take care of these 2 like big quadrilaterals, I'll be able to solve this problem, right? So in order to do this, let's try to say this is maybe beta. This is maybe alpha, right? Why I'm saying this? Because these 2 quadrilaterals, they're still missing. One is missing an alpha, one is missing a beta. So let's try to just denote them out using alpha and beta, right? So think about it. In this quadrilateral, B, C, D, N, I have what? Alpha plus 2 plus 3 plus 4 equals to 360 degrees. And in this quadrilateral E, F, G, M, I have 5, 6, 7, beta, right? They also equals to 360 degrees. I put them together. I have 2, 3, 4, 5, 7 plus alpha plus beta equals to 720. Is that right? So that being said, okay, let's do a quick comparison. I'm actually missing angle 1 here, right? Because the original question asked me to determine from angle 1 all the way to angle 7. I have already determined angle 2 plus angle 7. So I'm missing a 1. Plus, I have like an alpha plus beta, which I don't need. The question doesn't really need me to determine what is the value for alpha and beta, right? So my $100, like my $1 million question, not 100, my $1 million question will be what? Focusing how to find out the relationship between alpha plus beta and angle 1. And my work is done. Is that right? This is like the thinking process. And how can I find a relationship between alpha, beta, and our missing angle number 1? Which part I didn't use yet? Obviously, this is the triangle. I need to do my magic, right? This is the triangle. I need to do my magic. As long as I figure out what is happening within this triangle, my work is done. Okay, so let's check out this triangle. Whenever we focus on this triangle, oops, let's try to use here. Whenever I focus on this triangle, what can I see? I can see that this is actually a triangle with an internal angle and external angle. So what we can do, we're going to use the external angles property. External angle will be the sum of those two not adjacent internal angles. So angle alpha will be equals to angle 1 plus, this is angle 1 plus this guy. This guy equals what? 180 degrees minus beta. Is it right? I'm squeezing this in this corner. Angle alpha equals with angle 1 plus 180 degrees minus angle beta. So that being said, angle 1 equals to angle alpha plus angle beta minus 180 degrees. Is it right? Okay, that's it. As long as you have this, just plug in the value for angle alpha plus angle beta. That will be exactly equal to angle 1 minus plus 180 degrees. This is alpha plus beta plus angle 2, angle 3, all the way to angle 7 equals to 720. So at the end of the day, angle 1 plus angle 2 all the way to angle 7 will be 540 degrees. Is that right? So the correct answer for this problem is 540 degrees. I see many students already give out all the answers. Okay. So this is actually the direct solution for this problem. Okay. So let's do some quick extension or quick notes. What if you see this problem in AMC? If you really have no idea how to do this problem is fairly easy, right? I think you guys should be no problem. But what if I give you some weird shape? I have a lot of other angles. They're not even talking to each other. And the same thing, the question asks you to determine the total sum of those angles. What if this is the AMC? Can you have some shortcut rather than doing the hard calculation? You know, for our Canadian exams, for most of the time, you have no choice. You have to really present your work, right? There's no shortcut. But American exams, they're all using what? Multiple choices. So my question for you guys, if you have no idea how to do the calculation, can you use some shortcut to directly solve this problem in the AMC? Think about it. Think about it. If you see this problem, you have no idea how to do the calculation, can I have some shortcut to directly guess out the solution for this problem? This is actually very important, right? We always need to have a plan B. What if you have no idea how to do this problem? Somebody said, guess out. Okay, that's correct. But the $1 million question is, how do you guess? You can't blindly guess, right? Otherwise, you only have 20% of your probability. We just finished our probability, right? C1, C51 is only 20% for 5 options. And for Amy, there's like almost impossible. But how can you just guess out directly using some tricks and using some guidelines? These are actually considered as the the intuition of mathematics. So let me ask you a very brief question. So in this problem, all these shapes, all the quadrilateral or the triangle, they're just like a random quadrilateral and a random triangle, right? There's no specific angles. So that being said, at the end of the day, when you solve this problem, you're just trying to use the triangle total angle sum. In a triangle, say this, in a triangle, the total sum will be 180 degrees, right? In the quadrilateral, it's only 360 degrees. So that, I think that's actually the basic element you can do this break in, right? You can do this breakdown, right? Otherwise, there's no, I don't think you can go to anything smaller than this, right? Everything will base on this analysis. So that being said, using your intuition, you can guess out the final answer must be a multiple of 180 degrees. Is it correct? Because there's no weird angle here. If the question says angle 1 equals to 27 degrees, okay, in that part, there's no way for you to guess, right? But in this problem, it doesn't give you any information. Everything should be the random triangle, random quadrilateral, so on and so forth. So that being said, the minimum element you can do at the end of the day is basically doing this 180 degrees, 360 degrees, so on and so forth. So the correct answer for this problem must be a multiple of 180 degrees. Is it right? So if that's the case, if you really have no idea what to do, you know what? Pull out your protractor. You can actually have the protractor to go to AMC. Just manually measure all those angles one by one, okay? And then try to add them together. Of course, your measurement cannot be very precise, but not a big problem. Whatever, you just got maybe, I don't know, maybe 539. You just try to approximate to the nearest n times 100 degree, and that's gonna give you the correct answer. You guys follow me? This is actually a very important strategy. In the AMC, as long as you see some geometry problem, you have no idea what to do, try to use a protractor and try to use a ruler to have some accurate measurement and then pick up the answer, the closest answer from A, B, C, D, E, and you're good to go. Okay, this is a quick trick how to do such a problem in the AMC. You guys follow me? Yes or no? May I have some feedback? Yes or no? This is actually something very important, okay? Try to do it in a shortcut way. Sometimes that's gonna save you time significantly. Okay, let's go to our question number 2. Given a triangle ABC, BD and CE are both bisectors. Of BAC and BCF. If angle A equals to 27 degrees, please determine angle D. I'll draw the graph here. You have an angle AB, you have a triangle ABC. You have one bisector here, another bisector here. Two bisectors, they basically intersect at point D. This is E, this is F. If this guy equals to 27 degrees, please determine, see here, these two angles are the same, they are bisector. These angles are the same, they're bisector. If the question gives you what is the value for A, which is 27 degrees, the question asks you to determine what is the value for D. Think about it. I'll give you guys maybe 30 seconds. Try to think about how you're gonna do such a problem. These are all easy problems. Our lecture number 1, the triangle basic properties are all easy problem. So you should be able to solve this by yourself. Okay, let's check it out. For this problem, what are we gonna do? If you find an answer, post it into the group chat. These are easy warm-up questions, okay? How are we going to do for such a problem? So my understanding, you see, I'll show you what I see when I first saw this problem. So as long as you have the bisector, your first reaction is doing what? Basically saying these angles are the same, right? Let's say this is angle 1, and this is angle 2, right? Because all the bisectors, they have the same angle, so on and so forth. And still remember what I mentioned previously. As long as you see a triangle, they have an external angle. Your first reaction is always writing out the external angle equals the sum of those two not adjacent internal angle. Trust me, this is so easy, but this is so important. They will be used for every single problem. So that being said means what? Your BCF will equals to angle A, which is your 27 degrees, plus angle ABC. Is that right? This is like a conditional react, like I said. As long as you see this, conditional react, do not even think about the other stuff. Just leave them out. It might not be useful, not always useful for every single problems, but it doesn't hurt. You can always put a question out. Okay, now you know that BCF, this is actually a bisector. So it has two angles. So I can say 2, angle 2, right? Angle A, I have no idea, put it here, 27 degrees. And ABC, ABC actually 2, angle 1. Is that right? Now I find out the relationship for angle A, angle 1, and angle 2. But the question asked me for what? The question never asked me for angle A, or like angle 1 or angle 2. The question asked me for the angle D. So moving forward, the next step is doing what? You need to find out the relationship between angle 1, angle 2, and angle D, right? Relationship. So in mathematics, you are always trying to build up a connection between something you know and something you do not know. This is something you already know, right? 2, 1 plus A equals to 2, 2. This is something you do not know. It's angle D. Then the only thing that bridge you know and you do not know is actually the relationship. So as long as you figure out the relationship for angle 1 plus angle 2 plus angle D, they're kind of like thing whatever, and you'll be able to solve the problem. And who can tell me what's the relationship between angle 1, angle 2, and angle D? Can you type it into the group chat? What is the relationship? This is the thinking process. These are all easy problems, okay? We have difficult problems later, but all those easy problems, you can try to extract out the mathematical thought, which will be used for the difficult problems in the future. What is the relationship between angle 1, angle 2, and angle D? Who can tell me? Can you type it into the group chat? Yeah, as long as you put it into the group chat, I'll be able to see it. I'll be able to give you the feedback right away, okay? Yeah, I see some students that have the correct answer. How to find out the relationship between angle 1, angle 2, and angle D? Again, using what we talk about so many times. Let's check out this triangle. Angle 2 is the external angle of angle 1 and angle D, right? So again, I'm going to use angle 2 equals to angle 1 plus angle D. Is that right? Angle 2 equals to angle 1 plus angle D. So if I have this and I have this, I'll be able to just plug in the information. I'll be able to find out angle D is actually equal to angle A divided by 2. You just plug in, right? Replacing angle 2, angle 1 using angle D, and reaches 13.5 degrees. So easy, huh? This is a so easy peasy problem. As long as you understand our external angle equals to the two internal angle, like two non-adjacent internal angle sum, you're good to go. Is it good? Okay, if all good, another quick note. What if you see this problem in AMC? What if you see this problem in AMC? What if you have no idea how to do this and you want to determine the value? Some student says, measure the angle, but this, this part you cannot measure too accurate because angle 27 degrees, angle A equals to 27 degrees. It's kind of difficult, right? Difficult for you to measure. Round up or round down. But trust me, the solution, if I'm the author, the solution I'll give you this. 13.5, I'll give you 13.5, 13, and something like this. I'll give you this as ABCD. So for sure, I don't think you'll be able to figure out the answer. If you use your protractor, the protractor cannot be so accurate to all those kind of 0.5 degrees, right? If you give you the 13.5, 13, 12.5, 14, you still have no idea what to do. So do you have some other quick tricks to solve this problem without going into like a hard calculation? In our entire lecture, I'm going to teach you this trick, how to do some shortcut without doing the hard calculation. Let's just do some shortcut. Find the answer from ABCD and voila, that's it. How to do such a problem. Again, like I said, 27 is already there. So it means that you cannot set whatever value you want to set, right? But is there some other tricks for you to kind of bypass this calculation and directly figure out what you need? This is more like a brain teaser, right? If you know this, we just keep trying, keep giving you guys every single problem. I'll ask you the same question. And at the end of the day, after our 10th session, you'll be able to know how to do this quick tweak. Any ideas? We always use the easy problem to extract the important strategies. Think about it. We still want to do a quick tweak to solve the problem right away. I see some students, they have some directions, not necessarily have the correct answer, but have the directions. Let's check out from here. All right, now I understand this is 27 degrees. I can now do whatever I want, right? I follow you. However, the question doesn't say there's no restriction for B, right? Angle B can be whatever you want to be. The question doesn't say angle B must be like 60 degrees or 70 degrees, so on and so forth. So that being said, why don't you let angle B just equal to 60 degrees, right? Because angle B equals to 60 degrees, that doesn't change the problem, not at all. So if this is 60 degrees, you'll be able to determine the angle for here, right? This is going to be what? 30 degrees. You'll be able to determine this angle and this angle. Let me try to use a different color. So this angle can be determined. This angle can be determined. You use just basically divide by 2. You'll be able to determine these two triangles, right? So with this information, you'll be able to directly determine the value of angle D. Is it right? If I just let angle B equals to 60 degrees, everything will be so easy. You guys follow me? Yes or no? We just let angle B equals to 60 degrees. Why it doesn't change the result? That's a very good question, because the question doesn't get any involvement with angle D. Think about it. At the end of the day, I mean, it has nothing to do with angle B. At the end of the day, the relationship between D is solely determined by A. Angle D is 1/2 of angle A. It has nothing to do with angle B. And that's the reason why the question doesn't really give you angle B. So if that's the case, you just randomly pick a value, whatever value that works for you, right? 60 degrees, 90 degrees, whatever it works for you. And then you just do the calculation. At the end of the day, all your angle B value will be canceled out, right? And you only have to use the angle A value to determine the angle D. So that being said, you can actually, bypassing all the chaos, directly jump to the solution. And this strategy is actually very important. This is what we call enrichment. Enrichment means the condition given by the question is very primitive, very raw. But in order to solve the problem, what you can do is you can try to add a little bit condition. I want to add some value. I want to have more stronger conditions. So this is going to help me to solve the problem more efficiently. All right, try to learn this as we're going to talk about it more in the future. So a student having question, but how do we know that angle B is irrelevant before solving it? That's a very good question as well. If you really have no idea it is irrelevant or it is relevant, why don't you try twice? Let angle B equals to 60 degrees. Let angle B equals to 90 degrees, right? You calculate twice and they give you the same value. So that being said, you're in the right direction. You see, that's a very good question. I like you guys to interact with me during the lecture because your question always have a lot of like sparklings and I'll try to explain you. Okay, so do not really sitting there doing nothing. Please get involved, participate in the discussion. So any more questions regarding this problem? All good? All right, if all good, let's go to our next problem. Question 3. Question 3, I have to drag you the graph here. Yeah, we have a graph for this problem. I showed it before. So AA prime, BB prime are bisectors of angle EAB and angle DBC. AA prime equals to BB prime equals to AB. Please determine the value of angle BAC. Let's check it out. AA prime and BB prime, they are bisectors. So that being said, what? This angle equals to this angle. This angle equals to this angle, right? They are bisectors. And also the question gives you AA prime equals to BB prime equals to AB. So these are three angles. Let me change a different color. Help you to this two and this two. See, these three sides, they're actually the same in measurement. With all those information, the question asks you, what is the value for BAC? BAC. Think about how are we going to do for such a problem? This problem, I don't think you can just directly give angles, right? Because the question asks you what is the angle for BAC. I don't think you can randomly assign an angle to any kind of things, right? So think about it. How are we going to do for such a problem? Again, they're all using the basic properties we introduced today and solve it using all those kind of intuitions we talk about from day one. This one is a little bit difficult compared with the previous problem. I will give you 1 minute. Think about it before we go to the explanation phase. The thinking process is always very important. I wish you guys can basically follow us to learn this thinking process. How do you think whenever you see a problem? Think about it. How are we gonna, or how can we get started? That's actually the million-dollar question for all the students. As long as you see such a problem, what are you gonna do? The question asks you to determine the value for BAC, right? So maybe in that case, if you ask me to determine the value, I'm just going to zoom it a little bit, okay? I'm just going to say this value equals to X, okay? To make our life a little bit easier. X. Okay, if this is X, because AB is the same as B prime B, so this guy will be X as well. Is that right? If this is X, this is isosceles triangle, right? Isosceles triangle, again, like I keep saying, as long as you see an external angle, you will always think about it, the sum of those two non-adjacent angles. So that being said, you can check out this triangle. This is the isosceles triangle we're talking about, right? So this isosceles triangle, what are you going to do? You can always try to, I'm just going to zoom in here, okay? You can always try to do something like this. This guy will equals to 2x, right? But don't forget, BB prime is what? It's a bisector. So if this is 2x, this is also 2x. Okay? Okay, so let's move forward. I need to find out what can I do. In order to solve this problem, I need to put them into a triangle, right? If they're just like flowing there, no one's touching each other, there's no way for us to prove. Okay, if I know this guy equals to 4x, so this guy also equals to 4x. Is that right? Because they are the vertex, right? If this guy equals to 4x, don't forget, these two sides are actually also the same. Yeah, even my graph doesn't show this too well, but my triangle A prime, and B, this is also an isosceles triangle. So if this is 4x, this is also 4x. Okay, we're kind of close here, right? I have already used the condition, like all the isosceles triangles, so on and so forth. And I have already used the condition. This is what? A bisector, right? A bisector. Who can tell me which condition I didn't use it yet? Which condition I didn't use? Can you check it out? Every single condition given by the question must be valuable, right? You at least use them once. Which condition I didn't use yet? Maybe I can use that condition as a breaking point. Help me to solve this problem eventually. Who can tell me which condition I didn't use yet? The AA prime is a bisector, right? Okay, I think somebody have a correct answer. Yes, if that's the case, can you tell me by using the last condition, AA prime is a bisector, means these two angles are the same, right? How can we solve this problem? How can we solve such a problem? Our goal is to determine x, right? As long as no x, I'm good to go. But in order to determine the value for x, I cannot do them randomly. I need to find out a triangle. Like I keep saying from day on, triangle is the basic element for all our discussion, right? I need to find a triangle to start all my discussion. Who can tell me where I need to find out this triangle? How can I find this triangle? And how can I use this unused condition, AA prime as a bisector? If you understand these two parts, you will guide yourself automatically to the solution of this problem. Who can give me some input? Okay, I see many students already have the correct solution, at least the direction for this. I think my understanding, let's try to think about how I see this problem. You always need to find a triangle to fit in all those x, maybe using the total sum of x equals to 180 degrees and solve the problem thereafter, right? But the million-dollar question is, how can I find this triangle? Of course, I want to find a triangle which already has all my conditions, so on and so forth, right? So I find out actually this triangle is actually a very good candidate. So this triangle already has two angles I know. They're actually denoted by using x. And also like a white dot, right? Like this black dot. As long as I figure out the value for the black dot, my work is done. Is that right? So how to find out the value for black dot? I think this is kind of easy because this angle equals to 180 degrees minus x, right? And this black dot is only 1/2 of this, right? Due to the bisector. So divided by 2. So this is actually the value for this angle, right? 180 degrees minus x divided by 2. So moving forward, you just have to use in such blue triangle, you want to use 4x plus 4x plus 180 degrees minus x divided by 2 equals to 180 degrees. This is an equation. You can solve this equation, get x equals to 12 degrees. Okay? So far, so good? You see, as long as you find out the breaking point, every single thing is actually what we keep talking about from day one. See the external, always use the internal. The sum of the two internals which are not adjacent. And then you see the bisector, try to break it. And then put everything into a triangle, you'll be able to solve this problem fairly quick. Okay, so far, so good? Yeah, if all good, let's go to another question. Our question is becoming more and more interesting. Number 4. You have a right triangle, ABC. ACB equals to 90 degrees. AECF are bisectors. Of triangle CAB, of angle CAB, and angle DCB. CD is perpendicular to AB. With all those information, please prove. HF is parallel to BC. I'll give you the graph here. Go this way, I think. Yeah, here is the graph. You have A, B, C, D, H, E, F. Okay, so the question says something like this. You have a right triangle. This right triangle have ACB equals to 90 degrees. Okay, the top is 90 degrees. And AECF are bisector of CAB. So it means this is angle, these two angles are the same, and these angles are the same. Okay, so there are two bisectors. And also CD is perpendicular to AB, is the height in the hypotenuse. With all those information, the question asks you HF, which is the red one, is parallel to CB. Parallel to CB. I'll let you guys finish the writing. How are we going to do for such a problem? Again, it uses nothing but the basic technologies we just introduced. And you know what? Actually, this is a very important pattern. You know, in the geometry section, I'm going to give you a lot of very, should I say, very common pattern, every common shape. As long as you see this shape, you must have a conditional react. In the future, this shape must have such a property. So this is actually one-to-one mapping, okay? As long as you see this, you're going to automatically figure out, okay, this is something that I learned before. Some properties will have it before. So don't waste your time. You'll be able to figure out fairly quick. So I'll let you guys think about it one more minute. So try to find out some direction. How are we going to do this problem? How to prove HF is parallel to BC? You can actually post your answers into the group chat, and then we can take it from there. Who can tell me how can I find out, what is the breaking point, right? In order to prove HF is parallel to CP. Yeah, I see many students have a right approach. Yeah, they're trying to use like either similarity or using those two angles are the same in order to make it happen. That's perfect. You know what? Before we jump to the solution of this problem, I'd like to tell you this is actually a very, very important pattern. As long as you know that, as long as you see this pattern in the future, you will automatically have some very important property. Try to remember. As long as you see this, let's see, pattern, summary. As long as you see a right triangle, H, let's say CD, right? In our case, it's CD, is the latitude of hypotenuse plus you have two bisectors, right? This is exactly what the question tells me. You can automatically have two very important conclusion. One is AE is actually perpendicular to CF. AE is perpendicular to CF. Second, if I put this part as G, a given name to G, you can have CG is equal to GF. This is a common pattern. Please try to remember if you see something in the future, automatically you should have this. You have a hypotenuse, like a height in the hypotenuse, you have two bisectors, right? Automatically you have this. AE is perpendicular to CF. And also CG and GF, they are the same in measurement. Okay? So that being said means what? AE is the bisection of CF. Is that right? AE is perpendicular to CF and CG is the same as GF. It means AE is actually the bisection of CF. Is that right? Any objections? Are you guys following me? Yes or no? May I have some feedback? Please type your, please give me some feedback in the group chat. Are we on the same page? So that being said, okay, perfect. So that being said, AE is the bisection of CF. Later, I'll show you how to prove this. Okay, later I'll show you how to prove this. Okay, so that being said means what? It means, let me write it here. One angle bisector is the bisection of another angle bisector. Is it right? So what I'm trying to say for this, all those like formulas, if I use them, use the human language, this is actually summarized as a human language. The angle, we have two angle bisectors, and one angle bisector is actually the bisection of the other angle bisector. Is that right? If we know this, let's say if this is correct, I think if that's the case, this problem can be so easy to prove. Let's say this is angle, oops, change the color to here. If this is correct, okay, if this is correct. So that being said, this is angle, maybe this is angle 3, angle 4, angle 1, angle 2, okay? Just want to make it easier. Because this is bisection, right? I mean, this is bisector, angle 3 will be equals to angle 4, right? Angle 1 equals to angle 2, right? However, of course, you know angle 1 is equal to angle 3. Is that right? Angle 1 is equal to angle 3. This part, I think everyone knows that. Any objections? Any objections? Angle 1 equals to angle 3. Yes or no? Mm-hmm. Do you guys follow me? Angle 1 equals angle 3? Okay, no response. I'll take it as a no, okay? I'll give you some explanation. Why? This is also very important. You see, if this is a rectangle, so let's check out from here. I call this angle theta. So angle 3 plus angle, yeah. So if this is bisect, oh, no, angle 3 cannot, angle 3 equals to angle, okay, just give me one sec. Angle 3 equals to angle 2. Oh, yeah, of course. You can do it this way. Yes, that's actually easy. Let's see. Angle 3 plus this guy. ACG equals to 90 degrees, right? Angle 3. Let's say in this triangle. Because this is right? So angle 3 plus angle ACE is 90 degrees.
And at the same time, this is a right triangle, right? So angle 2 plus ACE is also 90 degrees. So that being said, angle 2 is equal to angle 3. You guys follow me? Angle 2 is equal to angle 3. So if that's the case, because angle 3 equal to angle 4, angle 1 equals to angle 2 equals angle 3, this is more like a parallel, right? So everything will be all together. Everything will be all together. Okay? So that being said, this angle is the same as this angle, same as this angle, same as this angle. Right? You guys follow me? Please give me some feedback if you follow me or not, okay? So these angles are all the same. Okay, if these angles are all the same, how can I prove HF is parallel to CB? Don't forget, I just proved what? AE is the bisection of CF. So that being said, HC will be equal to HF. Is it right? The point on the bisection must have the same distance to the two endpoints of the segment. Is that right? HC is equal to HF. So that being said, these two angles must have the same measurement. Is that right? Yes or no? Isosceles triangle, the two angles are the same. Okay, if you have this, you actually solve your problem directly. So you're looking at, let me change a different color, try to highlight it. You want to prove this segment CB is parallel to HF, right? So what do you have? Check it out from here. This angle is the same as this angle. So voila, you have your solution directly proved. Two angle 1 equals to angle 2. Of course, these two lines are actually parallel to each other. Is that right? So if I summarize the proof, I think that's like the proof is just like a couple of lines, right? Angle 3 equals to angle 4. Angle 1 equals to angle 2. Angle 2 equals to angle 3. All together, basically to 1, 2, 3, 4, right? And for sure, HC is the same as HF. So therefore, angle 1 will be equal to, let's say, angle 5, right? I call this angle 5. Angle 5. So therefore, angle 2 equals to angle 5. So therefore, HF parallel to CB. Is that right? Any objections? Oh, good, right? So that being said, as long as you know my conclusion, you will be able to solve this problem in no time. Okay? Well, the million-dollar question is, how can I prove this conclusion? How can I know if I have a perpendicular line, I have two bisectors, then automatically these two bisectors, one will be the bisection of the other guy, right? This is our million-dollar question. So let's try to prove this. As long as you prove this, we're good to go. Okay, I'm just gonna come here. I'm gonna re-drag it here. Rewrite it one more time because it's a little bit nasty there. I'm gonna show something like this, here, 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 right? So this is A, C, F, H, D, F, E, B, right? You have this guy equals to this guy equals to this guy. You want to prove this is perpendicular and also this is a bisection. Okay, let's check out from here. We have angle CAD is the same as BCD, right? CAD is the same as BCD. This part, you have any objections? This is what we just proved, right? This is what we just proved. So that being said, I'll give you a name angle 1, angle 1, angle 2, angle 3, angle 4. So that being said means what? CAD is angle 3 plus angle 4 equals to BCD, angle 1 plus angle 2. Plus angle 3 is equal to angle 4, right? Angle 1 is equal to angle 2 due to our bisector. So that being said means angle 1 equals to angle 2 equals angle 3 equals to angle 4, right? This is what we already proved. So let's just check it out from here. Angle 1 plus angle CHE equals to what? Angle 1 is here. This is my angle 1. CHE is this angle, right? My goal is trying to prove this is going to be a 90 degrees, right? As long as prove this is 90 degrees, so AE will be perpendicular to CF. My goal is trying to prove. Goal is to prove that it is 90 degrees. Okay, let's check it out. What is CHE? What is this CHE? CHE is what? It's the external angle of this triangle, right? We keep using the strategy we introduced from day one. It's the external angle of this triangle. So CHE will be equal to angle 3 plus ACD, right? Okay. What about ACD? What about ACD? ACD should be equal to what? 90 degrees minus angle 3 plus angle 4, right? Because this is 90 degrees. So ACD here will be 90 degrees minus angle 3 plus angle 4. Okay, but previously you know that angle 1, angle 2, angle 3, angle 4, they're all the same. So I will be rewrite it into 90 degrees minus 2 angle 1. Is it okay? Okay, if that's the case, what I'm trying to say, if I put everything together, it means angle 1 plus angle CHE will be the same as angle 1 plus angle 3 plus 90 degrees minus 2 angle 1. I just plug in the value, right? So angle 1 plus angle 3, because every one is the same, will be equals to 2 angle 1. So that one can be cancelled. Directly equals to 90 degrees. Directly equals to 90 degrees. So that being said means what? I have successfully proved CF is perpendicular to AE. Is that right? CF is perpendicular to AE. If you know that, think about it. My goal is trying to prove this is a bisection. Not only perpendicular is not enough. I want to also improve. I also want to prove the segment length is the same. But I think the following part is so easy. Let's check out these two triangles. Like the brown one in the top and the green one in the bottom. These two triangles, first of all, I have angle 3 equals to angle 4, right? Second, I have I just proved this is a right triangle. So it means the two sides are actually, they're both 90 degrees. And also they shared a common line in between, a common side in between. So these two triangles should be congruent to each other. Is that right? This is the angle side angle. Triangle ACDE G is congruent to triangle AFG. Give the name is G. Is that right? So these two triangles are actually congruent to each other. If these two triangles are congruent to each other, of course, CG will be the same as GF. Right? If I do a quick summary, I said angle 3 is equal to angle 4, and CF is perpendicular to AE. So, and also, what is that? The last one, AG is the common side. AG is the common side. AG is common. So altogether, triangle ACG is congruent to AFG. ACG is congruent to AFG. So therefore, I can see this is the bisection. You guys follow me? Yes or no? Can I have some feedback? Yes or no for this problem? This problem is long. I can't put everything into one page. Okay. So the $1 million question for this part is you need to remember a pattern. As long as you see a right triangle, a height in the hypotenuse, and then two bisectors intersecting to each other, you will automatically find out one bisector is actually a bisection of the other bisector. Bisection means they are perpendicular to each other, and one cuts the other into two equal parts. Are we all good? May I have some feedback? Yes or no? Okay, the other students, may I have some feedback? I know it's early in the morning, so people might a little bit drowsy, right? You might not really have time to, yeah, it's kind of like drowsy. Yes, I think that's pretty much what I want to say for the triangles, basic problem, like a basic property, right? I think we're not doing anything special, just like the basic things, right? Okay, moving forward, I want to talk another very important part for the triangle, which is the area method. How to determine the area. This is actually a very important topic for this triangle related section. These are also considered to be the basic things. So I think these are kind of bind with the basic property of a triangle. Because the triangle, you see what kind of property? You determine the area, you determine the angle, you determine the side, right? And then at the end of the day, when you have the side, when you have the angle, you want to determine the area, right? Let's try to have a look. How many ways for us to determine the area of a triangle? Okay, these are also something very intuitive. The first way is the basic way, right? You have triangle ABC. ABC. The area of the triangle will be equals to 1/2 A times HA, right? 1/2 B times HB, 1/2 C times HC. This is like, when you know this, you can graduate from junior kindergarten, right? Nothing to say. The second part is actually more useful in the math competition because you understand most of the time they won't really give you the height on the bottom, right? So instead, what you can do is something like this. A, B, C. This is A, this is B, this is C. Triangle can be 1/2 what? A times B. Like A times C times sine B. Let's do this one by one. AC sine B, right? Or AB sine C, or BC sine A. This one is actually more important in the North American math competition. Okay, Because let's say we take the first one. Let's say A times C sine B, because C times sine B is exactly the height, HA, right? So A times C times sine B is exactly the same as A times HA. Trust me, this is actually more important. I barely see in question, in our conclusion number 1, you need to find out the height. Most of the time, the question just directly give you an angle. You just do a sinus of the angle, you get what you need. This is also very easy peasy, right? So the third one, A, B, C. If the question only give you 3 sides, A, B, C, well, the question does not really ask you to really determine what is the height. You can directly determine the area of a triangle provided the 3 sides has been given. You're going to use the famous Heron's formula, right? I think that's what everyone knows. P equals to what? A plus B plus C divided by 2. And S will be equals to P times P minus A, P minus B, P minus C. Okay, this is like the Heron's formula. Okay, so far so good? I think these are pretty much the most important way how you can determine the area of a triangle, using the height, using sinusole, AB sine C, or using the Heron's formula. Okay, that's pretty much what you need to know talking about the area method. Okay, in the real exam, in the real competition, most of the time, this is going to be the combination between the 3 different methods. Later, I'll give you a problem. You'll see how to basically use them more dynamically. Last thing you need to know is something like this. A, B, C, let's say P. If 2 triangles, they are sharing the same height, right? So the area ABP, triangle ACP, the area difference between these 2 triangles will be exactly the bottom difference. Look, like the ratio, like the area ratio will be exactly the same as the bottom ratio, right? Provided they share the same latitude. Right? I think these are very understandable. This is our lecture number 1. This very understandable properties. Nothing will be flowery, but these are actually the basic for all our following discussions. Okay? If we're all good, let's go for one problem to demonstrate what we introduced up here. Okay? This is a question number 6. As shown in triangle ABC, EF is parallel to BC. AEF is the same as BCE. If triangle ABC's area is equal to 1, try to determine triangle CEF's area. This problem is fairly straightforward as well. A, E, F, B, C. This. You have a triangle ABC. EF is parallel to BC. If AEF is the same as BCE, talking about the area, AEF is here. BCE is here. These 2 triangles, they are sharing the same area. I mean, they have like the same area. If the entire triangle ABC has area 1, then how to determine the area of the CEF? what is the area of CEF? Think about it. How are we going to do for such a problem? Think about it. How are we going to do for such a problem? This is an easy introductory problem as well, but I want to use this problem to denote some very interesting, a very important mathematical thought as a wrap up for today's lecture. Yeah, I see somebody already gave me some big directions, which is perfect. So how do we do such a problem? So this problem, again, reflects a lot of interesting mathematical thought, which can be used in our later, more challenging problems. First thing first, the problem asks you to determine the area of triangle CEF, right? So as a common practice, if you ask me to determine the area of something, I'm just going to let it as X to make my life easier, okay? So I'm just going to put the value of triangle, the area of triangle EXC as X, okay? If this is X, because the entire triangle has an area 1, and the green one and the red one, they have the same area, so means both of them are 1 minus X divided by 2. Is that right? This is quite understandable, right? The total sum is 1 and they're the same, so 1 minus X divided by 2. Okay. So my next goal is pretty much trying to construct a function, right? And from this function, we might be able to solve out how to do this problem, so on and so forth. Okay, how can we construct a function? Okay. Very important trick. Important note. As long as you see parallel line, so the question gives you parallel, right? EF is parallel to BC. As long as you see parallel line, automatically you should have what? The areas ratio will be the similarities ratios perfect square. Is it right? If two triangles are similar to each other, so the areas ratio is the segment ratios perfect square. So this part, do you know this or not? May I have some feedback in the group chat? I'd like to see where we are. Can everyone give me a feedback? Do we know this or do we not know this? Okay, a lot of still do not know. Okay, in that part, I'll give you some explanation. So first of all, A, B, C, B prime, C prime. So first of all, do you know that triangle A, B prime, C prime is actually similar A, B prime, C prime is similar to triangle ABC. Do you know this? So let's answer my question one by one. I need to understand where we are. First question first. I have a parallel line, B prime, C prime, parallel to BC. So therefore, triangle ABC is similar to triangle A prime, B prime, C prime. Right? Is it yes or no? Can I have some feedback? I need to know where we are, okay? Before I can know how can we do this problem. Okay, most of the students, yes, okay? If you're not so familiar, not a big deal. We will talk about it later in our similarity section. Here, we just use some important property, and that's it. As long as you have this, then you will be able to see triangle A, B prime, C prime over ABC. So the areas ratio will be always the similarities ratios perfect square. So the similarity ratio will be A prime over AC, right? Two triangles that are similar to each other, the similarity will be A prime over AC. So the area ratio will always be the perfect square of the similarities ratio. Why? I'll give you a very quick explanation. Because triangle A, B prime, C prime, if I want to determine the area, it's 1 over 2 AB prime, AC prime, sine A. Is it right? This is the here. This is what we introduced here. Is it right? And I will do the same thing. ABC, 1 over 2, AB, AC, sine A, right? If I do a comparison, sine A will be canceled out. Will be AB prime, AB times AC prime, AC. Is that right? Okay, if two triangles are similar to each other, so AB prime over AB will be the same as AC prime over AC. Is that right? Do you guys follow me? Two triangles that are similar to each other, so the corresponding size, they will be proportional to each other. Yes or no? Do you guys know this? May I have some feedback? Do you guys know this? We're going to cover this in our future lecture, but I really like to know if you know this or not at this moment. Can I have some feedback? Yes or no? Two triangles, if they're similar to each other, so the corresponding size must be proportional to each other. This is a basic property for similarity. We will talk about it later in our lecture. If you're not so sure, not a big deal, we will talk about it later. So that being said, this is going to be AC prime, AC, perfect square. If you're not familiar, forget about it for now. You can just try to remember, okay, if two triangles. Okay, guys, I think we have a quick connection issue. Okay, now everything has been resumed. Can you guys hear me? Can you guys hear me? All right, something fairly quick. So previously, we just mentioned that what? If two triangles, they're similar to each other, so the area ratio will be the similarities ratio's perfect square. If you don't quite understand, not a big deal. We'll talk about it later because this is the last problem for our session. It might be a little bit difficult, so we're going to use a little bit knowledge we use in the future. So we just, okay, if you don't understand this part, try to take it. Try to take it, okay? So that being said means what? Means the triangle AEF, okay? This triangle and the big triangle ABC. So these two triangles are actually similar to each other, right? And the ratios difference must be the similarities difference perfect square. So if I drag it here, so I'm gonna say it one more time, try to make you guys understand. A, E, F, B, C. This is x, 1 minus x divided by 2, 1 minus x divided by 2, right? And said triangle AEF, triangle ABC, their area ratio will be exactly AF minus FC's perfect square. Try to take it for this moment. Okay, what about this? AEF over ABC. That's actually 1 minus x divided by 2 over 1, right? Because the big area is actually equal to 1. Okay, then what about AF over FC? AF over FC. This is actually the area of AEF and also the area of AEC. Their ratio. Is that right? This is exactly what we just introduced. Two triangles, they're sharing the same height, so the area ratio will be the bottom ratio. So far, so good? So that being said means what? AEF is 1 minus x divided by 2. AEC is actually AEF plus EFC, right? So that being said means 1 minus x divided by 2 plus x. Is that right? You just have to plug in here and you're good to go. So that being said means 1 minus x divided by 2 over 1 equals to 1 minus x divided by 2 divided by 2 plus x perfect square. So far, so good? So this is how we construct out such a relationship simply using x. With all of this, of course, this is going to be a quadratic equation for x. You'll be able to determine the x value equal to under root 5 minus 2. So that is actually the area of triangle ECF. And that's the solution for today's problem. Well, two things you need to know. First, if two triangles are similar to each other, so the area ratio must be the same as the side ratio's perfect square. This part, if you don't understand, we'll talk about later in our lecture. Second part is exactly what we mentioned. If two triangles, they share the same latitude, so the area ratio will be exactly the same as the bottom ratio. That's it. Using this, try to construct the function, you're good to go. All right, I think that wraps up our problem for today's lecture. And we basically introduced some basic properties for the triangles. And we introduced how to use these basic properties to basically solve some angle-related problem, or some side-related problem, and also some area-related problem. In the next lecture, we're going to continue on the area method and give you guys more interesting problem, how to solve the area ratio between different triangles. All right, I think that's pretty much what I want to say for today's lecture. And do you have any questions for me? All good? All right, in that case, I hope you guys enjoy the rest of the weekend, and I'll see you guys for the next week. Bye, guys.